All right, anybody out there thinking about getting that crane operator license? Maybe already a safety pro, maybe already a crane operator. Today is for you. We're going to be deep diving into all that technical knowledge you need to operate cranes safely and effectively.
Absolutely. And this is presented by Safety One Source. We're going to be going beyond the textbook, really understanding why this stuff matters when you're on that job site.
You got it. Think of this deep dive as your cheat sheet to OSHA 1926 Subpart CC, Appendix C. And that's the criteria for those crane operator written exams.
That's right. And even if you already got that certification, think of this as like a little tune-up for your knowledge. We're going to cover everything from the machine itself to the site conditions and even dive into those operational procedures.
All right, so let's imagine we're getting ready for that exam. We're just brushing up on our skills. This source material kicks things off with some general technical stuff about the crane. Makes sense, right? Got to know your machine inside and out.
Absolutely. It all starts with understanding what your crane can and can't do, what its functions are, its limitations, and, how those different attachments you might be using come into play.
Oh, yeah. It's like if you're using a clamshell bucket versus a standard hook, your whole approach changes, right?
Yeah, you got it. It completely changes the game.
And here's something that surprised me. There's a pretty detailed section about wire rope. I mean, it's just a cable, right? What's the big deal?
Oh, hold on there. Wire rope, that's like the heart and soul of a crane operation, You're talking about suspending massive loads from it, sometimes hundreds of feet up in the air. So yeah, it's pretty important.
I guess it makes sense when you put it that way.
The source material goes deep into inspection and removal criteria for wire rope. And trust me, that's crucial for preventing some really bad accidents, catastrophic accidents.
Right? Nobody wants to see that. And here's where it gets interesting. The capacity of a wire rope isn't just about how thick it is. Did you know it actually changes depending on how many parts are used in the rigging? Like if you have a multi-part line, it can handle a much heavier load than a single-part line, even if it's made of the same wire rope.
That's right. And the source material actually tells you exactly where to find that info. The manufacturer's data. That's your Bible when it comes to this stuff.
So it's like you're on site, you got to pick the right rope for the crane A&D, the lift you're doing. Knowing where to find that manufacturer info could make all the difference.
Absolutely. Choosing the wrong one, well, let's just say it's not going to end well.
Not at all. And it's not just wire rope we got to think about, right? There are all those other rigging devices, two slings, spreaders, lifting beams, all those fittings for wire rope, saddles, clamps.
Yeah, the source material covers the whole shebang.
It's like a whole toolkit for lifting stuff safely.
Exactly. Each one's got its own specific purpose, and knowing how to use them safely, that's mission critical.
Okay, so we got our wire ropes and rigging figured out. What about those electrical hazards? Those are everywhere on a job site, it seems like.
Well, that's where things get really interesting. OSHA doesn't just tell you to, stay away from power lines. They really get into the weeds with grounding, proximity warning devices, insulated links, even boom cages.
Like boom cages? What are those?
Oh, yeah. Those are like protective cages around the boom tip, to reduce the risk of touching those energized lines. But here's the thing. The source material also talks about how those safety measures aren't foolproof.
So they're not a guarantee, huh?
Nope. It's all about understanding those layers of protection. You can't just rely on one thing. Operators, they got to be super vigilant, keep those safe distances from power lines and microwave structures, all that stuff.
It's a good reminder, safety is all about having multiple layers of protection.
Exactly. Got to know the hazards, use the right safety gear, and always stick to those safe operating procedures.
Okay, now we're getting into something that sounds a little intimidating. Load share and transfer in multi-crane lifts. What's that all about?
This is where things can get pretty hairy. Imagine you've got two cranes working together to lift something huge, right? If that load isn't perfectly balanced or one crane has a problem, you've got a recipe for a disaster.
So it's not just about having two powerful cranes. It's about them working together perfectly.
You got it. Those operators, they got to be in sync, constantly talking to each other, making sure that load stays balanced. Even a small miscalculation, well, it could be catastrophic.
It makes you realize that good communication is just as important as the equipment itself.
Absolutely. And speaking of communication, that source material also reminds us how important it is to know those basic crane terms.
It's like learning a whole new language.
You got it. Imagine the signal person yells, "Boom up," and the operator doesn't know what they mean. Could be a big problem.
Right, bad news.
Knowing that lingo is like Safety 101.
All right, now let's dive into the inner workings of the crane. Machine power flow systems, mechanical, electrical, pneumatic, hydraulic, all the stuff that makes the crane go.
I know it might sound a little boring at first, but trust me, it's important. This is like the core of the crane. Understanding these systems can help you troubleshoot problems, prevent breakdowns, and even operate the crane more safely and efficiently.
I guess it's like knowing how your car works. If you hear a weird noise, you're more likely to figure out what's wrong if you know a little bit about the engine.
Exactly. And just like you wouldn't ignore those warning lights on your car dashboard, you got to pay attention to those gauges and instrument readings on the crane. They're telling you something important.
So those gauges aren't just for decoration, huh?
Nope. They tell you about hydraulic pressure, engine temperature, the weight of the load, all sorts of things. Ignoring them is like driving blindfolded.
Yikes. Okay, here's something I never really thought about before. The source material mentions thermal expansion and contraction in those hydraulic cylinders. Does that really matter?
It does. You know how temperatures change throughout the day? Well, that fluid in the cylinders, it expands and contracts, and that can actually affect how the crane performs, even its stability.
Wow, so it's like the crane is breathing almost, responding to the environment.
Uh-huh. It's one way to put it. Operators got to be aware of these changes, especially when it's super hot or super cold. Adjust how they operate. If they ignore it, they could lose control.
That's a little scary. Speaking of checking things out, this leads us right into those pre-operation and inspection requirements, right? It makes sense that knowing those crane systems inside and out would help you spot potential problems.
Absolutely. It's not just about going through the motions with a checklist. You got to be actively looking for wear and tear, any damage, anything that looks off, anything that could compromise the crane's safety or performance.
And don't forget about those safety devices and operational aids mentioned in all those other OSHA regs.
Yeah, those are there for a reason. Knowing how to use them, that's crucial. We're talking about anti-tube locking devices, load moment indicators, all that stuff. They keep the crane operating safely within its limits.
Got it. So, quick question for you listening out there. Is lifting always the same? What do you think?
Great question. This source material actually talks about the difference between duty cycle operations and lifting operations. Duty cycle is like repetitive tasks, think loading and unloading stuff. Lifting operations, those are more complex, more varied, and usually involve those heavier loads.
So like on a construction site, if you're moving materials around all day, that'd be duty cycle. But if you're setting a huge steel beam in place, that'd be a lifting operation.
Exactly. And that difference matters. It changes how you approach the task, the safety precautions you take, even the calculations you got to make.
And speaking of calculations, one thing you absolutely have to know is how to calculate the net capacity using the manufacturer's load chart. And here's the kicker. You got to do that for every single equipment configuration.
Right. It's not a one-size-fits-all kind of thing. Every time you change that boom length, use a different attachment, adjust the outriggers, you're changing the lifting capacity.
So you could be trying to lift more than the crane can handle if you use the wrong settings.
Exactly. And that's a recipe for a really bad day. Overloading a crane, it can lead to structural failure, the crane could tip over, even a complete collapse.
Yeah, that's definitely not good. And it's not just the crane's capacity, right? You got to think about those attachments too. I mean, can't a crane lift the same amount, whether it's using a hook or a clamshell?
Not always. Even using the right attachment changes how the crane works, so you got to adjust. If you use the wrong one or don't understand how it affects the crane's balance and stability, it could be a big problem.
Okay, future crane operators, here's a pop quiz for you. Imagine you're about to lift a load. Do you know how to figure out its dimensions, its weight, and its center of gravity?
Those are some key things to know. That's what determines how the crane reacts to the load. You can't just guesstimate. You got to have the right information to make sure you're lifting it safely.
And here's where things get really interesting. We're talking about dynamic loading.
Oh, yeah. Time to bring in a little physics.
Think about it. A strong wind hitting a suspended load, or that jolt when you start or stop a swing, or if you set the load down too fast. That's all dynamic loading, and it can completely change the forces on the crane.
It's not just the weight itself, it's how that weight is being moved and the forces that are acting on it.
And the source material even talks about side loading and its risks.
Oh, side loading, that's a big one. That's when a load is pulled sideways, which puts uneven stress on the boom. Imagine trying to lift something heavy off to the side instead of directly under you.
Yeah, you'd be much more likely to tip over.
Exactly. It's all about keeping that load centered, balanced, to avoid those side forces.
And to wrap things up here, we get a pretty clear explanation of those backward stability principles.
Right, that's all about making sure the crane's center of gravity stays over its base of support. Think of it like standing with your feet apart. You're more stable than if your feet are close together.
So if the crane's center of gravity goes too far back, it's like trying to stand with your feet together.
Yeah,
And you're much more likely to fall over.
exactly.
All right, we've covered a lot of ground here, from wire rope and rigging to all this stuff about dynamic loading. But remember, operating a crane safely isn't just about the machine itself. It's about the site, too.
You got it. And that's where we'll pick things up in the next part of our deep dive. We're going to be talking about assessing the site, identifying those hazards, all the things that can affect your crane operations outside of the machine itself. So stay tuned.
Welcome back. We're continuing our deep dive into that essential technical knowledge for safe crane operation.
And of course, big thanks again to Safety One Source for supporting this episode. We just finished going through some pretty heavy stuff about the crane itself, wire rope, all those rigging components, the power flow systems. Yeah, laying the groundwork, understanding the machine. That's step one. But now we got to zoom out a bit, focus on where that machine's actually working the site.
Right, got to think big picture. And if we're thinking like someone who's prepping for that crane operator exam, or maybe a safety manager going through a site inspection, this source material really hits on assessing ground suitability.
It's easy to forget what's going on under our feet. But think about it. Would you build a house on sand? No way.
Not a chance.
You got to have that solid foundation. Cranes, they put a huge amount of pressure on the ground, especially when they're lifting those heavy loads.
Makes sense. The source material actually gets really specific about identifying those weaknesses below the surface voids, underground tanks, loose fill.
Yeah, you could have a hidden cavern under your crane and not even know it.
That's a scary thought.
Those hidden dangers, they can really mess things up, make the ground weaker. It could look solid, but then it collapses under the weight. And it's not just what's underground. The surface itself can be a problem too. Think about retaining walls, slopes, excavations. All that stuff could shift under the weight of the crane.
So that's where those tools come in, the mats, the blocking and cribbing, the outriggers, stabilizers, crawlers.
Yeah, they're like giving the crane extra feet, right?
Yeah.
Helps to spread that weight out evenly.
Like setting up camp. You wouldn't pitch a tent on uneven ground without securing it, right?
Exactly. And just like you'd check your campsite for hazards, like poison ivy or wild animals, you got to be super aware of those site hazards when you're operating a crane.
Power lines, piping, anything that could get in the way.
Yeah, and think about swinging a load into a live power line.
I don't even want to imagine that.
Not a good picture. Operators need to be 100% clear on what's around them and make sure there are no surprises.
And here's something I hadn't really thought about before. This source material really talks about reviewing the operation plans with everyone, not just the crane operator.
That's so important. We're talking supervisors, crew members, the signal person, everyone working around that crane needs to be on the same page.
So it's a team effort.
Absolutely. Communication, communication, communication. That's the key to a safe and smooth operation.
Yeah, it's easy to think that everyone knows what's going on, but when you're dealing with these big machines, you can't take any chances.
Exactly. You don't want any misunderstandings. Take working height, for example. Everyone needs to know how high that crane's going to be lifting and what that means for clearance around the site. Same thing with boom length, the load radius, the travel paths. Everyone needs to be aware.
So everyone needs to be in the loop.
Exactly. Got to keep everyone informed to keep everyone safe.
Okay, so this is a question for everyone out there thinking about becoming a crane operator or maybe already doing site safety before you even lift anything. Do you know if you have enough space for all that equipment? Have you factored in how much room you need for those crawlers to extend or those outriggers? And then there's the counterweights.
Right. It's not just the crane itself. You got to consider all that other stuff too.
And you need to be able to maneuver safely.
Exactly. Running into an obstacle mid-operation, that's a whole other problem you don't want to deal with.
No kidding. Okay, so we've talked about the crane. We've assessed the site. We've got everyone on the same page with our plan. Now it's time for the main event. What does this source material have to say about actually operating the crane?
Well, even before we touch the controls, this document stresses smooth and safe movements, throughout the whole lift. That means picking the load up smoothly, carrying it without any jerky movements, swinging it carefully, and then setting it down nice and easy.
Like a delicate dance.
Yeah, kinda. Whether you're operating on tires or outriggers or crawlers, that smoothness, that control, it's all about keeping the crane stable.
So I guess experience really plays a role here.
Oh, absolutely. Operating a crane, it's not something you learn overnight. It takes practice, training, a good feel for the machine.
So even if you're a seasoned pro, There's always more to learn, new techniques to master.
For sure. And that brings us back to communication. Even the best operator in the world needs to be talking to their team, listening to feedback, being open to suggestions.
Makes sense. Now let's get a little technical for a minute. The source material actually gets into reeving wire ropes.
Yeah, reeving, that's basically threading the wire rope through the crane's pulleys and blocks, and there's definitely a right way and a wrong way to do it.
It's like threading a needle, but with, like, industrial-sized equipment.
Aha, great analogy. The source material lays out how to do it right, both for single and multiple part lines, and how to pick the right load block and ball. If you mess that up, you could weaken the whole system.
So we've prepped the site. Everyone's communicating. We've got our ropes reeved perfectly. Anything else to keep in mind during the operation?
One of the biggest things this document emphasizes is being adaptable. On a job site, things don't always go as planned. Imagine a sudden gust of wind or an obstacle pops up.
Yeah, it's like a video game where you got to react to all those unexpected challenges.
Exactly. Operators need to be able to think on their feet, adjust the plan, make those safe decisions in the moment.
So it's not just following a script. You got to know how to improvise safely.
Right. And thinking ahead, this document also reminds us about properly shutting down and securing the crane when you're not using it. Seems simple, but it's easy to forget when you're busy.
I can imagine someone thinking, oh, I'll just be a minute, and they leave the crane running with the boom up, but then something happens.
Right, and that minute turns into a big problem. Could be a gust of wind, someone messes with the controls.
Not good. Speaking of things you can't always predict, let's talk weather.
Ugh. Mother Nature. Always keeps things interesting, right? The source material is all about checking those manufacturer's specs for operating in different weather conditions.
So not all cranes are made the same when it comes to wind and rain and temperature.
Nope. They've got different tolerances. Operating a crane in high winds, that's a whole different ballgame than operating it on a calm day. The wind can really push that crane and that load around.
So you got to respect those forces of nature.
Absolutely. Speaking of forces, this document reminds us to double-check both the load weight A and D, the weight of all that rigging, before we lift anything. Remember all that talk about capacity and dynamic forces?
It all comes full circle.
Right. You got to know exactly how much weight you're dealing with, rigging included, to make sure you're not overloading the crane. That's a recipe for disaster.
All right, future crane operators, one more scenario. You're about to lift a load. Do you know where it's going? This source material actually talks about figuring out those pickup and placement points and how to verify the radii.
Planning and precision, that's what it's all about. No room for guessing when you're moving heavy stuff around.
Makes sense. And speaking of checking things out, the source material brings up those shift inspection requirements again. Really knowing those crane systems makes those inspections a lot more meaningful.
It's like the pre-flight check on a plane, making sure everything is in order before you take off.
And in the case of a crane, those checks could literally save lives.
No doubt. Now get ready, because things are about to get serious. The source material lists a bunch of operations that are, well, they're a whole different level. We're talking multi-crane lifts, hoisting personnel.
Whoa, that's like the expert level.
Yeah, you could say that. Clamshell and dragline operations, pile driving, working with concrete, demolition, operations on water, magnet operations. It's a long list.
Those sound like some pretty specialized skills.
They are. These operations come with a lot more risk, so you need that extra training, that experience. They're not for beginners.
So if you see someone doing one of these, you know they're at the top of their game.
Absolutely. These are the pros. Now, the source material doesn't just list these complex operations. It also gets into specific procedures for working in certain conditions. What about traveling with a suspended load?
Oh yeah, that sounds tricky.
It is. You got to maintain a steady speed, no sudden movements, and you got to keep your eye on that load the whole time. Watch for any swaying.
Okay, how about approaching a two-block condition?
Oh, that's a big no-no. That's when the two blocks on the hoist line come together. You could damage the rope or even pull the load back up into the boom.
Yikes.
Operators need to be really careful, keep an eye on that distance between the blocks, and stop the hoist well before they touch.
So it's all about prevention.
Absolutely. Okay, next up, operating near power lines. I always get a little nervous thinking about that.
Me too.
It's definitely risky. You got to keep a safe distance. Always be aware of that potential for arcsing or electrocution. Even a tiny mistake could be really bad.
Definitely don't want to mess with that. And then there's hoisting personnel. I can't even imagine the responsibility of that.
Yeah, that's serious business. You need the right equipment, strict procedures, and a really skilled operator. You're literally responsible for people's lives.
If I ever see someone operating a crane with a personnel platform, I'm going to give them a salute.
They deserve it. Okay, let's keep going. What about using less than the full extension on those outriggers or crawlers?
Does it matter?
It can. It can affect the crane's stability, so you got to adjust the load chart and be extra careful.
Okay, how about lifting loads from underwater? That sounds like a challenge.
It is. You got to think about how much the load weighs in the water, the resistance, and any currents or other hazards down there.
So many things to consider.
Right. And what about different counterweight configurations? We talked about that a little before, but it seems like there are so many variables.
Yeah, it can be hard to keep track of.
Changing that configuration, it shifts the crane's balance point, so you got to understand how that affects the load chart and how you operate.
So you got to stay on top of it. What about handling loads you can't even see?
That can be tough. But if you've got good communication with your signal person and you really understand how that load is moving, you can do it safely. It takes trust and spatial awareness.
So it's a team effort again.
For sure. Now, what about using those electronic communication systems for signals instead of hand signals? Seems like that could be helpful.
Yeah, especially if it's noisy or you're far apart.
Right. But you got to have a backup plan just in case that equipment fails or there's interference.
So don't ditch those hand signals entirely.
Nope. Still need those sometimes. And finally, load control and tagline. Use any thoughts on those?
Those sound important.
They are. Load control is all about using those crane controls to keep the load stable. No swinging or spinning out of control. Taglines, those are ropes attached to the load that people on the ground can use to guide and steady it.
So it's like having extra hands to help manage that load.
Exactly. And you need good communication between the operator and the people holding those taglines.
All right, we've covered so much. But before we move on, we got to talk about emergency procedures. Knowing what to do if something goes wrong, that's critical.
Couldn't agree more. This source material, it covers all kinds of emergencies: fires, power line contact, losing stability, controls malfunctioning, tube locking, overloading, even problems with the carrier or travel mechanisms.
So it's like a safety manual for worst case scenarios.
Exactly. It's not just about preventing those accidents, it's about knowing how to react if something does happen.
So training is important.
Absolutely. Operators need to be trained on those procedures, practice them, and know exactly what to do in those stressful situations.
It's like knowing CPR, you hope you never need to use it, but you're ready if you do.
Exactly. And that training, that practice, it can really make a difference when things get tough.
Right. Deep breaths, everyone. We've talked about the crane, the site, the operation, even emergencies. What's left?
Well, we've saved the best for last: load charts.
Load charts. I've always found them kind of intimidating, all those numbers and diagrams and technical terms.
I know what you mean. They can be a bit much at first. But trust me, load charts, they're your best friend when it comes to safe operation. Think of them like the instruction manual for the crane. Ignore them, and you're asking for trouble.
So how do we make sense of these mysterious load charts?
First things first, you got to learn the language, all those terms. If you don't know what they mean, you're going to be lost.
So it's like learning another language?
Pretty much. Once you've got that down, you got to make sure you're using the right chart for your specific crane setup. Boom length, attachments, outrigger positions, counterweights, all that stuff changes the load chart.
Wait, so one crane can have multiple load charts?
You bet. It's not one size fits all. Using the wrong one, that's like using the wrong recipe. Things are not going to turn out right.
Okay, so we've got the right chart. We know what all those words mean. Now what?
Now you got to dig into that information. The source material talks about those operational limitations, those footnotes we all love to ignore, and how to use the chart for different crane setups: crawlers, outriggers, jibs, counterweights, all of it.
So much information packed into one chart.
Right. It's like a roadmap for safe operation.
One thing I've always been confused about is the difference between structural capacity and capacity limited by stability. What's the difference?
Okay, so think of structural capacity like this. It's the maximum weight the crane can handle before it starts to break, like how much weight a bridge can hold before it collapses.
So if you go over that, you risk damaging the crane itself.
Exactly. Now, capacity limited by stability, that's the max weight the crane can lift before it tips over, becomes unstable. Like how much weight you can carry up a ladder before it gets wobbly.
So structural capacity is about the strength of the crane, and stability capacity is about balance.
You got it. Both are super important for staying safe.
The source material also talks about what's included in those capacity ratings. It's not just about the weight of the load itself.
Yeah, you got to factor in the rigging, the hook block, any other attachments you're using. It all adds up.
So those numbers on the load chart, they're the total weight.
Exactly. And don't forget about those range diagrams and work area charts. You know, those diagrams with all the lines and curves.
Yeah, I've seen those.
Those are visual representations of the load chart. They show you how much the crane can lift at different distances and boom angles.
So they're like a visual guide to help you make sense of the numbers.
Exactly. And one last thing, the parts of line information. Remember all that talk about reeving wire ropes and those multiple part lines?
Yeah, more parts of line, more strength, right?
Right. The parts of line info on the load chart tells you how that reeving configuration affects how much the crane can lift.
Wow, so much to learn about load charts.
There is. They're packed with info, but it's not just about memorizing numbers. You got to know how to use them in the real world.
So load charts are essential, but they're not the whole story, right?
Right. You got to be aware of what's going on around you, talk to your team, and be ready for anything.
And of course, you got to know how to actually operate the crane.
Well, yeah. Now, what about those load moment indicators and load moment devices we've mentioned before? Where do those fit in?
Those are those electronic systems that monitor the load and stability in real time, right?
Exactly. They're like a digital safety net for the operator. They can tell you if you're getting close to overloading the crane or becoming unstable.
Like a second set of eyes.
Exactly.
Yeah.
Especially helpful for complex lifts and tricky situations.
Okay, I think we've covered just about everything. Wire rope, rigging, load charts, the whole 9 yards. Safe crane operation is definitely a multifaceted challenge.
It is. It's not just about knowing how the machine works. You got to understand the physics, the engineering, the site conditions, the communication, how people work together.
It's like a whole ecosystem.
Exactly. Everyone's got a part to play in keeping things safe.
Well said. Big thanks to Safety One Source for their commitment to safety and for supporting this deep dive. Make sure you all check out their resources.
Definitely worth a look.
And to everyone listening, we hope you found this helpful. But remember, this is just the beginning of the journey.
Keep learning, keep practicing, and always put safety first.
Now, here's something to think about. Given everything we've talked about, what steps would you take to make your next crane operation as safe as possible? Talk about it with your team, and let's all work together to keep things safe out there.
Absolutely. We can all learn from each other.
Until next time, stay safe and lift smart. And we are back for the final part of our deep dive on safe crane operation.
We've really covered a lot of ground, haven't we? From the nuts and bolts of the crane itself, all the way to site assessments, communication, and those oh-so-important load charts.
It's been quite a journey, but we've saved the most important part for last, the human factor.
We've talked about the technical stuff, the situations that can come up, but in the end, it's a person up there in the crane cab making decisions.
And as much technology as we have, as much engineering and regulations, human error, that's still a big reason why accidents happen.
It's like, you can have all the best safety gear in the world, but if you forget to buckle your seatbelt, you're still at risk.
So what are some of those human factors that can lead to problems?
Well, this source material talks about things like fatigue, being tired, complacency, getting too comfortable, distractions, rushing, poor communication, even just having a bad day.
Yeah, we've all been there.
All that stuff, it can affect your judgment, your reaction time, your ability to make the right call.
It's a good reminder that even the most experienced operator, they're still human.
Exactly. And that's why operator training and making sure they're qualified is so important. It's not just about knowing how to work the controls, it's about understanding what the crane can and can't do, the safety principles, how to recognize those hazards.
It's about having that safety mindset, always being aware of the risks and taking those steps to stay safe.
Right. And that mindset, it's got to go beyond just the operator. Everyone on the job site, they got to be aware of the dangers and take responsibility, look out for themselves and each other.
It's like a team effort creating that culture of safety.
Exactly. Everyone looking out for each other, communicating, following the rules.
And, we all make mistakes. If you see someone doing something unsafe, don't be afraid to say something.
Right. You could be saving a life. And it's not just about preventing accidents. It's about learning from them, too. If something does happen, you got to figure out why, get to the root of it, and fix it so it doesn't happen again.
And let's not forget about staying up to date. The crane industry is always changing. There's new tech, new safety practices all the time.
That's why it's so important to stay on top of it, training, certifications, going to those industry events.
Gotta keep learning.
Exactly. If you get complacent, that's when accidents happen. Always got to be trying to improve, be safer, and learn from our experiences.
So as we wrap up this deep dive into crane safety, what's the big takeaway for our listeners?
I think the most important thing is that safe crane operation, it's not a one-person job, or one simple thing. It takes technical knowledge, being aware of your surroundings, communicating clearly, having that safety culture, and always being willing to learn and improve.
It's about the people, the environment, the systems, everything working together.
It's a whole system, and everyone has a part in making sure cranes are operated safely and efficiently.
Well said. A huge thank you to Safety One Source for their dedication to safety in the crane industry and for sponsoring this deep dive. We encourage all our listeners to check out their resources. They've got some great stuff.
It's been a pleasure talking about this important topic today.
And to our listeners, we hope you found this deep dive helpful and interesting, but remember, this is just the beginning of your journey into crane safety. Keep learning, keep practicing, and always, always put safety first.
Here's one last thought for you to chew on, given everything we've talked about. What would you do to make sure your next crane operation is as safe as possible? Think about it, talk about it with your team, and let's all work together to make this industry safer for everyone.
That's it for us. Until next time, stay safe and live smart.